All right, so we're picking up where we left off yesterday. So yesterday we just had one inequality that we graphed. So we're going to start by doing that again, just to remember how to do everything. So we want to graph the inequality y is less than negative 1/2 x plus 4. So before you can graph, what form do we have to be in? Slope intercept. Is this in that form? Yes, because we've got y by itself. So where are we going to start? 4. So we're going to go up to 4. 1, 2, 3, 4. And then we've got to count our slope. How do we count the slope there? Down 1, right 2. How are we going to take that the opposite direction? Good. Up 1, left 2. Are we going to connect that with a solid or a dotted line? How do we know that it's dotted? There's no equal to on there, so it's got to be a dotted line. Good. So now all we have to do is shade. Since it says y is less than, does that tell you to shade above or below? Below. So if I'm over here, is this above or below the line? What about over here? So that's the direction we want to shade, yeah? So we talked about this briefly yesterday. What this says is that any solutions for this inequality are going to fall in that shaded area. So any ordered pair that is in like the part that we've colored. Does that make any sense? So today we're going to have 2 of them. So your solution for 2 inequalities, we call it a system of inequalities, is going to be where they overlap, okay? So I've got that written for you over here. So this is like the key thing you need to know. Your solution is where you overlap. So that's why we've got colors. So we're going to use 2 different colors, and our answer is going to be where you have both colors. Is that okay? So let's try that with number 1. So, like I said, we're using colors. So I like to underline the one that I'm graphing in the color that I'm using for it, so I know where it came from. So that's what I'm going to do with the first one. I'm using purple for that first one. So they're both already solved for y, so you don't have to worry about doing anything there. So let's graph our first inequality. Where are we going to start? 2. So we'll go up 2. And then how are we going to count our slope there? Down 5, right 1. How are we going to take that in the opposite direction? So we're going up 5, right 1. That's one. Are we going to connect those dots with a solid line or a dotted line? Dotted, because it's not an equal to, so we've got to have that dotted line going on. And it says y is greater, so does that tell us to shade above or below? Above. So is that going to be option 1 or option 2? Option 2. So we're going to go this way. Now I like to draw lines when we start having systems instead of like really coloring it in, just because it's easier to tell where you overlap sometimes. But if you want to like fully color it, that's totally fine too. So now we're going to do the same thing, graph this second one on top of this one. So if we're looking at our second inequality here, I'm going to use green for this one. Where are we going to start? Okay. So 1, 2, 3, 4, 5, 6, 7. How are we going to count our slope there? Down 3, right 1. How do we take it to opposite direction? Up 3, left 1. Right 1, left 1, left 1. That way 1. The other way. That's okay. All right, are we going to connect with the solid or dotted line? Solid. How do we know it's solid this time? Because we got that equal to. And it says y is greater. So do we shade above or below? Above. So that's going to go the same direction as last time, right? So we're still shading this way. So now you should start to see a part of your graph where you've got both colors going on. Do we kind of see that? So we said that our solution is going to be where you have both colors. So I like to go back, and if you did it in pencil, which is totally fine if you did, you can erase the parts of your graph that are not in our solution, so like where you don't have both colors, or like I did it in pen, so I can't erase. So I'm going to highlight what's part of our solution set, so that would be all of this stuff. If you want to just like circle it with your pencil, that's fine too. As long as you can tell me or show to me that you know where your solution set is. So again, anytime you've got a system of inequalities, your solution set is where they overlap, so where we've got both colors going on. So if we had a point that was way out here, would that be part of your solution? What if we have a point in here? Why not? It's not where both colors are, so this point wouldn't work. What if we had a point up here? That would work because it's where both colors are. Is that okay? What if we had a point right here? So I'm talking about this point right here. Could that work for our solution set? Why? Still in the shaded area. And this is a solid line, right? My green line was solid because we had the equal to there. So that means that anything that falls on that line works. What if it was a dotted line there instead? It can't be part of your answer. Does that make sense? So if a point falls on the dotted line, it's not part of your solution set. Do we have any questions right now? Anything we're not sure about? Don't understand? Y'all ready to try another one? Okay. So looking at number 2, if we want to go ahead and graph the first inequality, we're good to do that, right? Is this good to go in this form? Yeah? Okay. So let's graph the first one, then we'll worry about the second one. So Bailey, where are we going to start our graph for the first inequality? -3. Sierra, how are we going to count our slope? Yes, ma'am, up 2 over 1. Catherine, are we going to have a solid or dotted line there? For the first one? Dotted, yeah. Why is it dotted, not solid? Exactly, it's not equal to. Keelan, it says y is less than, so are we going to shade above or below? Below. And is that going to be option 1, y'all, or option 2? Option 2. So we need to graph that second inequality. Are we good to go and start doing it right now? I see some heads shaking. Why not? It's not in slope-intercept form. We've got to get it in that form. So Michael, how are we going to do that? Minus 2x, because we want to get y all by itself. So we're going to have y is greater than or equal to negative 2x plus 2. Is that in slope-intercept form now? Yeah, so we're okay to go ahead and graph from there. Natalie, where are we going to start our line? 2. Noah, how are we going to count our slope? So how do you count that? You got it, down 2 over 1. Julia, is that one going to be a solid or dotted line? Solid. How do we know that it's solid, y'all? Equal to, good. Chloe, it says y is greater than, so is that above or below? Above. So y'all, is that option 1 or option 2? 2. So we're going to shade above that line. So where's our solution set going to be? Where you got both colors, where they overlap. So is that happening here? What about here? 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 Yes. So I'm going to color this section because that's our solution set. So if I have a point over here, is that part of our solution set? No, because nothing's shaded over there. What about here? No, why not? It's only one color. So what about down here? No, why? So just one color. So what about here? That's okay. What about here? Is that okay? What about here? Why is that point not part of our solution set? That falls on a dotted line. So even though it's in that like colored area, because it's on the dotted line, we can't count it in our solution. Does that make any sense? So dotted line, can't count. Solid line, can. Is that okay? Questions? All right. Correct. You got it. That's exactly right. Do we need to like make a note of that somewhere? Would that be helpful? Yeah, let's write that. So what did we say? If a point falls on a dotted line. So I said if a point falls on a dotted line, we cannot count it as part of our solution set. Is that okay? Do we need to add anything else to that? It'd be helpful if I have that so you can actually read it. That was gross. So let's look at number 3. What is wrong with both of those inequalities right now? They are not in slope-intercept form, so we've got to solve both of those first. So let's just start with the first one, the top one. So we've got y minus 5 is less than negative 1/2 x. How are we going to get y by itself there? Add 5. Is it in slope-intercept form now? Yeah, so we're good to go ahead and graph that. Hallie, where are we going to start? 5? 1, 2, 3, 4, 5. Ashley, how do we count our slope? You got it, down 1/2. So the opposite direction there should be up 1, left 2. Abigail, are we going to have a solid or dotted line? Dotted. And how do we know that it's dotted, y'all? No equal to there. Dotted line. Now it says y is less than. So Ethan, do we shade above or below? Below. So is this below the line? Is this below the line? So that's the direction we need to shade. So now we can look at our second inequality. So again, is this in slope-intercept form? No, so we've got to get it there. So we've got y minus x is greater than or equal to negative 1. How do we get that in slope-intercept form? Add x. So y is greater than or equal to x minus 1. Then we can go ahead and graph from there, yeah? So, Megan, where are we going to start? Negative 1. Good. Rylan, how are we going to count our slope? Up 1 over 1. Yeah? Over and over and over. How are we going to take it the opposite direction? Anybody know? So we're counting our slope up 1 over 1. How are we going to take it the opposite direction? Down 1 over 1. Jacob, is that going to be a solid or dotted line? Why is it solid this time? Because why? Because it's equal to Riley, it says y is greater than. So which direction are we going to shade? Above. So y'all, is this above? Will this be above that line? Yes, so that's the direction we want to shade. Where is our solution set going to be? Where our colors overlap. Yeah, where we've got both going on. So that's this little slice over here. My highlighter is dying. we okay with that?
Yes.
Everybody all right? Yeah? Okay. So for number 4, can we try that one on our own?
Yes.
Yeah? All right. Do we need to go through the steps on how to do that together, or can I put it up here and you check yours? Can you like do it and then I put the answer and we'll just be like, oh yeah, I got that, or oh no, I didn't get that. Is that okay? All right, let's do that. So y'all are gonna work on it. I'm gonna work on it at the same time and we'll come back together. Before you get too far gone, what's one rule that we have to remember when you're solving inequalities? If you multiply or divide by a negative, you've got to put that inequality sign. So be careful of that. Actually, do y'all just want to get them in slope intercept form and then stop? Can we do that and then do the rest together? Let's do that. So just get them in slope intercept form. And then we'll check that because I don't want us to get too far gone. Alright, looks like most of us are done. So this is what we should have gotten when we solved for y on both of those. So for your first equation, we should have ended up with y is greater than 8x minus 4. Now why did our inequality sign switch there? You divided by -1/4 or multiplied by -4. Either way, it's the same thing, right? And since we multiplied divided by a negative, you have to flip that inequality. Did we get here?
Yes.
Do we have any questions? So we're okay with that one? Can we go ahead and graph that one? Yeah? Alright. So, let's see. Austin, where are we going to start? Okay, well this is what it's supposed to be. So where should we start graphing that? You always start at your y-intercept, and ours is -4, so we're going to go down 4. 1, 2, 3, 4. Joe, how do we count our slope? Our slope, how do you count it? How do you count your slope? Up 8 over 1. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Now we don't really have room to count any more than that. We're going to run out of graph. Y'all, are we going to connect that with a solid or dotted line? Dotted, because it's not an equal to this time. Tori, it says that y is greater than, so do we shade above or below? Above. So is this above the line? Yeah, it kind of is this time. So we're going to shade this direction. And then looking at our second equation, we had to solve that for y as well. So we had 4x plus 8y is greater than 4, and you get y all by itself. You should have ended up with y is greater than negative 1/2 x plus 1/2. Are we okay with that?
Yes.
Yeah?
Yes.
Do we have any questions on how we got there or what we did? Because some of us didn't solve the last one correctly, and then we didn't say anything. So are we actually okay on this? If you're not, it's all right, but I need you to let me know so we can talk about it. Okay, so where would we start graphing this? Y between 0 and 1. Because it's half, right? And half falls right in between what? 0 and 1. Halfway between 0 and 1. So there's not like a line for it, but you've got to go in between those lines. So that would be our y-intercept on this one. It's kind of hard to see. I wonder if I can like zoom in here. Ooh. There we go. All right. So, so if we're at 1/2 for our y-intercept, how are we going to count our slope here? What is our slope on this one? Negative 1/2. So that means go down 1 block and over 2 blocks. So if we go down 1 whole block, we're still in between. Does that make sense? So when you graph this line, you're not going to be falling on good points, right? It's going to be in the middle of those blocks. So just be mindful of that. So we're going down 1 and over 2. That should have been positive, shouldn't it? Yeah, let me goof. Mine is not. Dang it. Okay, I'm going to shut this whole thing up. It's all right. So your y-intercept should have been positive 1/2, and I did it at negative 1/2. I think I was looking at the slope. Correct. Let me see if I can wipe this out. How's that? Is that better? Yeah. Okay. Alrighty. So we got that line graph. Y'all didn't have to do it twice. Great. I only me messed up. It's okay. Are we gonna have a solid or dotted line there? Dotted. And it says that y is greater than. So are we going to shade above or below? Above. So is this above the line? Is this above the line? Yes, so that's the direction that we're going to shade. I'm going to pull this up a little bit. Alright. So, now we just got to find our solution set. So again, where's your solution set going to happen? Where you've got your two colors overlapping, where our graphs overlap. So that happens in this little slice up here. And that is that. Do we have any questions there? Anything we're not sure about, don't quite understand? We will in a minute. We're going to do a couple word problems next. Yeah, fun stuff. Alright, so let's see. The first one on the back, we're talking about cherries and grapes. So cherries are going to cost us $4. $4 a pound. Grapes are $2.50 a pound. You can spend no more than $15 on fruit, and you need at least 4 pounds in all. So we're going to create a system of inequalities to model that, and then we're going to graph it. I can't remember if we graphed this one by hand or not. So we're going to have two equations, right? Everything we've been doing before, we had two inequalities. So one of our inequalities is going to talk about the money that we're spending, and one of them is going to talk about the pounds of fruit that we have. Okay? So if we're talking about money, what do they tell you about money? What information do they give you? Cherries are $4, that's money. What else do they tell us about money? Grapes are $2.50. Anything else they tell you about money? Spend no more than 15. So that's going to be our first inequality. Is that okay? So what variable do y'all want to use for cherries? What do you want to use for grapes? Can we use y? Only because we're graphing and we don't have a g-axis on our graph. That's okay. Are we okay with that? Are we good? You could use like c's and g's if you really wanted to, but then we're going to have to make them x and y's to graph it later. So we'll just go ahead and do x's and y's now. So to write cherries cost $4 a pound, how much you write that in math? 4x, exactly. So say 4x. Grapes are going to cost us $2.50 a pound. So how do we write that? 250y. And is it going to be plus 250 times 250 minus 250 divided by 250 plus, because we're just adding however much cherries cost plus however much grapes cost, right? Plus 250y. Then we said we could spend no more than $15. So we know that on the other side of our inequality, we're going to have 15. So if this is what we're spending, can it be bigger than 15? No. So do we need a less than, greater than? A less than? Do y'all want to make it equal to? Totally up to y'all. I don't care either way. We'll put equal to on it. Are we all right with that? Yeah, what's up, Haley? I don't care. If it's like very specific and it tells you got to be equal to or whatever, then we'll put it in there. But otherwise, it doesn't really matter so much. Anything else? Are we okay so far? All right, so then our next equation, we said we were going to have one for money, and then we're going to have one that talks about how many pounds of fruit we have. So how many pounds of cherries do we have? Do we know? Do they give us any specifications? Like you've got to have this much. Do they say? We just know that we have some number of cherries, right? So what do we put when we don't know? X. What about grapes? Do they tell you how much grapes we have to have? How many pounds of grapes you have to have? So what do we put when we don't know? Why? Are we going to add those two together, multiply them, divide them, subtract them? Add. So however many pounds of cherries plus however many pounds of grapes needs to be at least 4 pounds in all. So on the other side of our inequality, we're going to have a 4. And it says at least 4 pounds. So do we want to get more fruit than that if we can? Yeah, so this side should be bigger. Do you agree? And so we'll make that a greater than. Do y'all want to make it equal to? Okay. Totally up to y'all. I don't care either way. And it doesn't specify, so either way is fine. So the next thing that it wants us to do is to graph this. So we are actually going to graph it on your calculator. Are we going to graph it on your calculator? Actually, no, we're not. I lied. Never mind. Sorry. We can do this one by hand. Can we do this one by hand? Yeah, we'll do this one by hand. So, if we are going to graph these, what form do they have to be in first? Slope-intercept form. So, we've got to get what by itself? Your y. So, which one do you want to do first, top or bottom? Top? Okay. So, for the top one, we've got 4x plus 250y. It would be helpful if I wrote the right number. Oh, man. 4x plus 250y less than or equal to 15. Okay, we've got to get y by itself there. Sonia, what's the first thing we need to do? Yep. Minus 4x, good. And that's 4x, so we're going to have 250y less than or equal to negative 4x plus 15. Haley, what do we do from there? Divide by 250. So we're going to have y less than equal to. So in your calculator, we've got to figure out what 4 divided by 250 is. So when you type that in, we'll do negative 4 divided by 250. What do we get? Negative 1.6. Now that's fine. Decimals are okay. But do we like decimals if we're graphing? Why not? We've got to graph rise over run for your slope, right? And that's what that number is going to end up being. So it's more helpful to have it as a fraction, right? Do you know how to convert this to a fraction in your calculator? Let me show you. So from here, we're going to hit menu, and we're going to go to number. And then you've got an option that says approximate to fraction. That's what we want to do. We want it to convert that to a fraction for us. And so we'll hit enter, and it's going to tell us that it's negative 8/5. Is that okay? So that would be our slope, yeah? So we'll have negative 8 over 5x. And then we've got to do 15 divided by 2.5. 6. So we'll say plus 6. And is that in slope-intercept form now? Yeah, so we're good to go ahead and graph that. Haley, or not Haley, I just told on you. Thomas, where are we going to start? At 6. 1, 2, 3, 4, 5, 6. Bailey, how are we going to count our slope? You're exactly right. Down 8 over 5. Noah, are we going to have a solid or dotted line?
Solid.
What do y'all think, solid or dotted? Solid, only because we made it an equal to. If you left it as a not equal to on your paper, then you could have a dotted and that's fine. But we've got an equal to, so we're going to make this a solid line. That was a test. You passed. Yeah, me too, obviously. So a solid line. Are we good with that? Solid, not dotted. Solid. Then we gotta shade it. So it says y is less than. Does that mean shade above or below, y'all? Below. So is below gonna fall this way? This way? Yeah. So we'll shade this way. Maybe I won't mess up on the next one. So we've still got to graph our second one. We've got x plus y is greater than or equal to 4. Can we graph that just like it is right now? What do we have to do first? Solve for y. So we've got, let's do this in green, x plus y greater than or equal to 4. We've got to get y all by itself. Catherine, how are we going to do that? How are we going to get y all by itself? So we want to get rid of the stuff that's not y. So what's over here that we want to move? X. So it's like x plus y. So what would be the opposite? Instead of plus x, what would we need to do to move it? Minus x. Make sure that you're writing this down. Is that in slope-intercept form now? Yeah, so we're good to go ahead and graph it from there. So let's see, 0, where are we going to start that line? Yes, ma'am, at 4. 1, 2, 3, 4. Thomas, how are we going to count our slope? You got it. Down 1 over 1, over and over and over. Riley, are we going to have a solid or dotted line? Solid. For real solid this time. I'm not going to do it dotted on accident. Hallie, it says y is greater, so do we shade above or below? If y is greater? Above. So is this above? Is this above? Yes, so we're shading everything this direction. So where is our solution set going to be? Where are the two colors? What? Where they meet, where they overlap. So you got to look really, really close. It's this tiny section in here, right? Right in this area where they overlap. We've got both colors going on. So we're talking about how many pounds of cherries and grapes and how much they cost and all this stuff, right? So this is like real life, yeah? X for us was cherries. So if we had a point that was out here, that would be like negative 3 pounds of cherries. Can we buy negative 3 pounds of cherries? No. So we know that our answer is not going to fall in this quadrant ever, right? What about down here where both X and Y are negative? So negative pounds of cherries and negative pounds of grapes. Wouldn't work there either, and it's not colored there, so that's not going to work. And then in this quadrant as well, this would, we had down here, would be like negative pounds of grapes. Could that work either? No, so it has to fall in quadrant 1. So if we're talking about quadrant 1, the section where both colors happen, is this itty bitty little triangle right here. And that's it. So really, really small solutions up there. Do y'all remember how we were talking about like with real life stuff, it's almost always going to happen in that quadrant 1. So that's why we've got to narrow it in here. So it's only going to happen there. And yeah, that's it. Do you have questions on that? Can we say like what a possible solution would be? Can we do that? Can you find a point that falls in that area? One, 2, 3, 4. Somebody said 1, 4. Yeah, that falls in there, so that would work. So we could say like 1, 4 works. I think that's about the only good point in there. But can you buy like decimals of pounds of fruit? Do they let you do that? Yeah, so we could have a ton of possibilities in there as well. So 1, 4 is one option, but then there's a bunch of other ones as well. Do you have any other questions right now? Okay. So for the last one, the numbers are not going to fit on our graph. So all we're going to do is set up the inequalities. Is that okay? That's what they're going to ask you to do a lot on your exam and on your tests and stuff. They want you to set up the inequalities, not necessarily do anything with them, but they want to know that you can take the words and write equations to go with that. So what are we talking about? So we got a job mowing lawns. It's going to pay us $12 per hour. We also have a job at a clothing store that pays $10 an hour. You need to earn at least $350 per week. So I'm seeing money, money, money. I'm going to underline that. We got money, money, money. You can work no more than 35 hours each week. We need to create a system of inequalities to model that situation. So very similar to the one that we did before, you're going to have one inequality that's talking all about money. And then we're going to have another inequality that's talking about our hours. So if we're talking about money, what do they tell you about money? What information do they give you that involves money? Mowing lawns pays $12, yeah? What variable do you want to use for mowing lawns? X, so we'll say lawns is X, and you get 12 per hour there, so how could we write that? 12X. What else do they tell us about money? Clothing store pays you $10 an hour. So what variable do we want to be for their clothing store? We could use Y there. So we'll have 10Y. Are we going to add 10Y, subtract 10Y, multiply 10Y, divide, add? Anything else they tell us about money? At least $350 per week. So we're going to have $350 on the other side of our inequality. And if it says at least $350, do we want to earn more if we can? Yeah, so does this side want to be bigger or smaller than $350? Bigger, so let's put a greater than. Do y'all want to make it equal to or not? Yeah? Okay. Again, it doesn't really matter if they don't specify. And then, what else does it say? It says you can work no more than 35 hours each week. So do we know how many hours we're mowing lawns? So what do we put when we don't know? X. So however many hours mowing lawns. Plus, do we know how many hours we work at the clothing store? So plus Y. However many hours we work at the clothing store. And then we want to be no more than 35 hours each week. So 35. If we can work no more than that, can this side be bigger than 35? No, so we need a less than there. Do you want to make it equal to? Yes. Y'all like your equal to. Are we okay with that? Alright, so again, we're not going to grab that one. We're going to skip that part. We're just setting up the inequalities. Do you have questions on where any of this stuff came from? Questions on anything we've talked about today? Y'all ready to try some on your own? Yes. All right.